For section 2.5, we're going to be writing a function rule. Before we get into the problems, we need to understand how to turn a verbal phrase into a numerical expression. So here are some examples. So for the first one, it says 5 more than x. The numerical expression is x plus 5. What you need to look for here is the word than. If it has the word than, more than, we know the more means we're going to add. So we will add, but the than means we want to put this behind the x. So it's 5 more than x, so we want to put x followed by the more or the plus of the 5. Okay, so that's how you want to work with that one. All right, the next one says 5 less than x. Again, the than is given, so we're going to subtract 5 from the x, but we want to do it as x minus 5. So you want to subtract from behind. So you want the x first followed by the subtraction of the 5 because of the word than. The next one, the product. The product means to multiply. So the product of a number and 5. So we're going to multiply the number, which we'll call n, and 5. Now we're going to write it as 5 times n because we want to put the 5 first before the n, or 5n. The next verbal phrase, the quotient. The quotient means to divide. So anytime you see the word quotient, it means to divide. Divide of a number and 5, or it's going to be n divided by 5. Okay? The last one, 5 more than, again, there's the than. That means that the 5 goes at the end. 5 more than twice a number. Well, twice a number means to double the value of the number, which is n, or 2n. And then since it's 5 more, we're going to put the 5 at the end here. So it's 2n plus 5. All right, now that you see some of these examples, now let's start with example 1. Okay, for problem number 1, we're going to use these 3 examples from what we learned just earlier. So for A, we have y is 5 less than the product of 4 and x. So the key word here is less than and product. From earlier, we said that if it has the word than, we want to put that at the end. So we're going to go ahead and write y is means equals 5 less than. Okay, so that means we're going to put the 5 on the back, and it's a subtraction. 5 less than. The product means to multiply 4 and x, so we're just going to put 4x. So our equation is y equals 4x minus 5. Okay, now for B. The landfill has 50,000 tons of waste in it. Each month, it accumulates an average of 420 more tons of waste. Write what equation is a function rule that represents the total amount of waste after m months. Okay, so let's look at some important things. The landfill already has 50,000 tons of waste in it. Okay, so that's going to be a constant. Each month, it's going to average about 420 more tons of waste. Okay, so more tons of waste. Okay, we're going to represent m as the number of months. So we're going to go ahead and write an equation. The equation is to represent the total amount of waste. So total amount. So we're going to go ahead and start by changing the total amount. We're going to say that the total amount, we're going to call that T. Okay? Now, T is going to equal, T is the total amount of waste, is going to equal to the initial amount of 50,000 that's already in there. So 50,000 tons. And let me write that a little bit clearer. 50,000 tons, okay? And it's going to accumulate an average of 420 more. So we're going to add 420 more each month. And each month is m. So therefore, it's 420 per month, or for each month. And any keyword you're looking for is per, each. So that tells you if there's a rate going on, that means we're going to multiply that by a variable, which is m. So it's be 420 times m. And then that would be your equation. For C, it gets a little bit more complicated. Now you have a word problem, but it's the same thing. Let's go ahead and read this one. You can estimate the temperature by counting the number of chirps of a snowy tree cricket. The outdoor temperature is about 40 degrees more than, so again, important things we want to highlight are more than, 1/4 the number of chirps the cricket makes in 1 minute. What is the function rule that represents this situation? Okay, so first thing is it's based on temperature. So we're going to be using temperature, or T. So again, we're going to be using for this one, we're going to use T for temperature. Okay, and the outside temperature is about 40 degrees more than 1/4 the number of chirps. So again, if we go back to key things here, the number, let's call that n. All right, now we're going to make an equation. Okay, to write this as an equation, okay, the outdoor temperature is, so we're going to call the outdoor temperature, or in this case, our T here, T is, that means it's equal, is about 40 more than. Again, when you see 40 more than, that goes on the back. So we're going to put 40 more than. Okay? The next thing it says, it's 1/4 of the number of chirps. And we're going to say the number of chirps is n. Well, 1/4 is a fraction. So we're going to say 1/4, 1/4. 1/4 of the number of fractions, so 1/4 times n. And so here's our equation. The outside temperature T equals 1/4 n plus 40. And that would be our equation. Okay, for problem 2, we're going to do the same thing. We're going to write a function rule, but now we're going to solve it based on the information they give us. So for problem 2, a kennel charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. Write a function rule for the total cost for n number of days of boarding plus a bath. So the total cost, that's this right here. That's what we're solving for. So this is going to represent C. The total cost is based on the number of days of the boarding, which is charged up here. It tells you how much it is. The boarding charge is $15 per day, but they want us to use n for days, so we're going to go ahead and say 15 times n. So the cost is going to equal, total cost is the number of days of boarding, which is 15 times n, plus the bath. Well, the bath, that's going to be a cost of $12. So that's going to be plus 12. So that means our equation is going to be C, and I'll just go ahead and write it over here. C equals 15n plus the bath of $12. And so there's our answer to writing the function rule. So I'll just go ahead and get rid of this so we don't get confused. I would just say that this is the cost. Okay, so, and this, the number of days, was the 15n. All right, so there's our equation, but we're not done. How much does a $10 day stay cost? So that means we need to find out what's the cost after 10 days. Well, since this is our equation, we're going to go ahead and substitute. The value that we're going to substitute here is going to be n. N is going to equal 10 for the number of days. So then we're just going to go ahead and solve for this. And so we're going to say that the cost is going to equal to 15 times 10 15 times 10 plus 12. Well, that's 150 plus 12. The cost is going to equal to $162. So that would be our answer right there. Alright, for problem 3, we're going to be writing a nonlinear function rule. Okay, so this one won't be a straight line. Write a function rule for the area of a rectangle whose length is 5 more than its width. What is the area of the rectangle when its width is 9 feet? So the first thing we need to do is show, and what I did is I brought the picture here of the rectangle. Since it's talking about area, we're going to use the formula area equal to length times width. But we don't have a length. What we have is that length is 5 more than its width. So the first thing we want to do is substitute the value of L, the length. So for L, our length, okay, is really, length is 5 more than. So when you see 5 more than, that means we put the 5 behind. 5 more than its width, so that's W. So length can be viewed as 5 plus, W plus 5. So we're going to go ahead and change the L and replace the L on the picture with W plus 5. So now we're going to multiply the length, which is W plus 5, times its width. And so therefore we're just going to rewrite the formula as A, which is really length times width, but we're going to substitute L as W plus 5. So there's our length times its width, so times W again. Now we're going to go ahead and simplify this. So area is going to equal to W plus 5 times W, and what we're going to do is we're going to distribute the W out. So what we get is our area is really just W squared plus 5 times W. So now that we have our function rule, we're going to go ahead and find the area when its width is 9. So we're going to go ahead and substitute W for 9. W is going to equal to 9. So now we go ahead and plug it in. So area is going to equal to W is 9, so it's really just 9 squared plus 5 times the value of W, which is 5, so this which is 9, so 5 times 9. Okay, so 9 squared is 81, plus we're going to add 45. So if we find the area, 81 plus 45 is going to equal 126. So the area is 126, and since it's based on feet, we will say feet squared. So there's our answer. Okay, so this is our last problem. Everything we're doing here is based on coming up with an equation based on the word problem. Please remember the keywords like more than, quotient, product, less than. Okay? If you have any questions, bring them up tomorrow. Till then, we'll see you. Bye.